The next topic is thermal expansion of solids. In this expansion, there are two types of solids. The first one is isotropic solids. Second one is anisotropic solids. Okay. In isotropic solids, the expansion is same in all directions. In anisotropic solids, the expansion is not same in all directions. Okay. In isotropic solids, the expansion is same in all directions, but in anisotropic solids, the expansion is not same in all directions. Okay. Now I am going to explain in the case of isotropic solids. So in the isotropic solids, let us consider cuboid whose length, breadth, height. So along this, when it is heated, a solid whose length, breadth, height are present are heated, then you will get expansion along the three sides. So for example, I am considering a cuboid, okay, whose length, breadth, height are given. Okay. Then what happens? These length, breadth, height will be changed when they are heated. So the initial length is noted as L1. Initial temperature is noted as T1. Next, final length is noted as L2, and final temperature is noted as T2. Okay. So for example, I want to explain the expansion in a single direction. If the expansion is going to take place in a single direction, then that type of expansion is said to be coefficient of linear expansion. That coefficient of linear expansion is represented by alpha. So to explain this, let us consider a rod. Of initial length L1 at temperature T1. Now this rod is heated so that this rod is expanded up to this. This is the change in length. Now this total length from initial point is noted as L2 at temperature T2. That means there exists a temperature difference noted as T2 minus T1, and there exists a length difference noted as L2 minus L1. Okay. So when this is possible, when L1 is present, that L1 depends on the change in temperature as well as change in length. Okay, so there exists a coefficient of expansion named as alpha. So this change in length depends on L1, and this change in length depends on delta t. So the coefficient of linear expansion is defined as the ratio of change in length by initial length multiplied with the temperature difference. The units is per degree Celsius. Per degree Celsius. So that means this formula is also noted as L2 minus L1 by L1 multiplied with T2 minus T1 per degree Celsius. This alpha is called coefficient of linear expansion. This can be defined as the ratio of change in length to its initial length per degree centigrade rise in temperature. That means if delta T is equal to 1 degree Celsius, then alpha is present only delta L by L1. That is called a fractional change in length. So this alpha is called what? Coefficient of linear expansion. This coefficient of linear expansion is defined as the ratio of change in length to its initial length per 1 degree centigrade rise in temperature. Okay, if it is 1 degree Celsius, then this alpha is equal to delta L by L1. Okay, so now in skill problems sometimes they will ask like this: alpha is how much? Alpha is equal to L2 minus L1 by L1 multiplied with delta T. Then if you want only delta L, okay, then you can write like this: alpha L1 delta T. Alpha L1 delta T. Instead of this delta L, you can write like this: L2 minus L1. L1 alpha delta T. This minus L1 move this side. L2 equal to L1 plus L1 alpha delta T. Okay, now L2, take L1 as common, 1 plus alpha delta T. So this L2 is called what? This L2 is called the final length after heating. To get the L1, then you can write like this. So this value is taken as upside, then you will get like this also. So for example, I want to find the temperature difference, then you can write like this. To get the temperature difference by knowing the fractional change in length and alpha, you can write like this. And only if you want to find the temperature difference, only T2 delta T equal to T2 minus T1 or not. So instead of find T2 equal to T1 plus delta L by L1 alpha. So this T2 is called what? Final temperature. Okay. Thank you for watching. Please subscribe my channel Sri Sai Physics for Mains and NEET. Okay, thank you.